Good afternoon, all of you. Last class we discussed the ideal solution in the solution part in the solution video 2. So today we'll start the non-ideal solution. So before we start the ideal non-ideal solution, first just recap of the ideal solution. According to Raoult's law, partial vapor pressure of a liquid A or any liquid is equal to the product of mole fraction into vapor pressure of its pure state. So this coming from Raoult's law. Now any solution which obey Raoult's law throughout the whole range of concentration is called ideal solution. Generally, no solution obey this equation. Like as we know that PV equal to nRT. This equation is called ideal gas equation. But generally, all natural gases do not obey this equation at the natural temperature and pressure. So these gases are called real gas. So similarly, the solutions are not obey these equations. So these solutions are called non-ideal solution. So what is non-ideal solution? Non-ideal solutions are those solutions which do not obey Raoult's law throughout the whole range of concentration. These are called non-ideal solutions. Non-ideal solutions are of two types. One is called positive deviation. One solution shows positive deviation from Raoult's law, and another one negative deviation from Raoult's law. Now, what type of solution which shows positive deviation from Raoult's law? First we plot vapor pressure versus composition graph. This is vapor pressure and that is composition. We know that suppose we consider two liquid A mixed with liquid B, and both are volatile liquid and they form a completely miscible binary liquid solution. Clear? So we consider two liquids A and liquid B, both are completely miscible and both form a binary liquid solution. Now over here chi A equal to 1 and chi B equal to 0, and here chi A equal to 0 and chi B equal to 1. So when chi A equal to 1, it indicates only liquid A is present, and when chi B equal to 1, it indicates only liquid B is present. So here when only liquid A is present, so the vapor pressure indicates the pure vapor pressure of liquid A, and when only liquid B is present, then it indicates pure vapor pressure of liquid B. So here I consider A is more volatile than B. That's why the vapor pressure of A is higher than that of B. You can consider reverse also. P naught B is higher than P naught A. But remember that they cannot be same. Vapor pressure of two different liquids at a particular temperature cannot be same. Because if this is same, it indicates the molecules or the force of attraction between the molecules are same, or molecules are same. So suppose if you mix some water in water, then you will not get the water solution. So that's why the different liquid indicates they have different molecules, and since they have different molecules, the force of attraction is different, and that's why the vapor pressure is also different. So according to Raoult's law, if we plot vapor pressure versus composition graph, we will get graph like that. Why? Because partial vapor pressure is directly proportional with the mole fraction. Follow. When we move from left to right, chi A decreases, mole fraction of A decreases, corresponding vapor pressure also decreases, and when the mole fraction of A becomes 0, corresponding vapor pressure becomes 0. Similarly, chi B increases, corresponding vapor pressure is also increases, and when the mole fraction becomes 1, means only liquid phase is present, then the vapor pressure is P naught, and it indicates vapor pressure of the solution. Now, positive deviation. So this graph, this line are expected from Raoult's law. If the solution behave ideally, then you can get this type of line. But experimentally, if we get this type of graph, then the solution shows positive deviation from Raoult's law. Sir, why it is called positive deviation? Follow. Suppose we take a point over here, and in this point, at this point, this line is called liquid B. So this point, this is the vapor pressure PB expected from where? Expected from Raoult's law, and this line PB experimental. So what does it indicate? When the experimental vapor pressure is higher than that of expected vapor pressure from Raoult's law, then the solution shows positive deviation from Raoult's law, and it is non-ideal solution. Clear? So for the positive deviation of Raoult's law, experimental vapor pressure is higher than expected vapor pressure from Raoult's law, and negative deviation just its opposite. So when again vapor pressure versus composition graph, again chi equal to 1, chi b equal to 0, chi a 0, chi b 1, here p naught a, here p naught b. So if the solution behave ideally, then you expect this type of line. But if the experimental vapor pressure becomes lower than expected, it is lower than expected, then the solution shows negative deviation from Raoult's law. So if we draw a line from here, so this is expected PB expected from Raoult's law, and this is PB experimental or observed. So when experimental vapor pressure is lower or observed vapor pressure is lower from the expected vapor pressure from Raoult's law, then the solution is non-ideal solution, and which shows negative deviation from Raoult's law. But there is some reason. When two liquids are mixed, liquid A and liquid B are mixed, then it may behave as ideally, it may be not. But why? What is the reason behind it?